Hello everyone, myself I am B. Srikar from Information Technology branch of IRE College. Today I am going to explain a topic from database management systems. Let us go into the topic, and title is about Smart ATM Secure, a secure ATM management system, which means we are going to implement a smart ATM secure system. Okay, our next slide is problem statement. A traditional ATM systems face challenges such as security vulnerabilities, unauthorized access, and inefficient transaction handling. Sensitive banking data requires high levels of protection and consistency. There is a need for a secure, reliable, and database driven ATM system that ensures safe transaction and database management. Okay, which means in traditional ATM systems, it faces a security vulnerabilities and unauthorized access and inefficient transaction handling. So that system needs a secure system, secure ATM system to avoid the challenges like security vulnerabilities, unauthorized access, and inefficient transaction handling. Okay, and our next slide is objectives of our title, which means topic to design a secure ATM based by robust database to ensure accurate and consistent transaction processing using DBMS concepts, to implement user authentication and data protection mechanisms, to provide fast and reliable banking services such as withdrawal, deposit, and bank inquiry. And our next slide is about, okay, the current slide is about system overview. How the system will be there means smart ATM Secure is a database-centric application that manages ATM operations. It connects users, ATM machines, and bank servers through a structured database. The system handles real-time transactions, account management, and security verification. It will provide a seamless interface between users and banking data. The overall system will be the system will connect to the users, ATM machines, and bank servers through a structured database, and it will provide a seamless interface between user and banking data. Okay, and our next slide is about database design. How the database will be designed means the system uses a relational database model to store structured banking data, which means it will store a relational database management, which means like RDBMS, the data will be stored. Uh, it will store the data in the form of tables, and tables are designed to store user details, account information, transaction records, and ATM logs. As I said, the data will be stored in the form of tables. The tables are designed to store user details, account information, transaction records, and ATM logs. And relationships between tables ensures data consistency and integrity. And the normalization is applied to reduce redundancy and improve efficiency. As we know the concept of normalization, it will reduce the redundancy and improve efficiency to reduce the redundancy, which means duplication of data will be reduced through normalization. Okay, and our next slide is maintain tables in database. How to maintain the tables in database means user table stores customer details like name, account number, PIN, and accounts table will maintains account balance and account type, and transaction tables will maintain records all ATM operations such as withdrawals and deposits, and ATM logs like ATM logs tables will maintain like track system usage and access history for security monitoring. Okay, and our next slide is functional requirements. Okay, let us see the functional requirements of smart secure ATM. The system must allow users to authenticate securely using PIN or credentials. It should support withdrawal, deposit, balance inquiry, and mini statement operations. The system must record wait a minute, every transaction in database Admin should be able to monitor system logs and detect suspicious activities. And our next slide is non-functional requirements. Okay, what are the non-functional requirements? Means the system must ensure high security to protect sensitive banking data. It should provide fast responsive time for real-time transactions. It should provide a fast response time for real-time transaction. For example, we went to a ATM. If we try to deposit, withdraw a money of 500 rupees or something else, if it takes 1 hour or 2 hour to withdraw money, what is the use of ATM? So our system, which means our smart ATM system, which means application, it should provide a fast response time for real-time transactions. Within seconds, we have to perform operations. Okay, the database must maintain high availability and reliability, which means in the database, the data should be available all the time for the users, and it should reliability, which means in real time it should be available. Okay, and the system should be scalable to handle multiple ATM users. Why it is important means the database must maintain high availability. Sorry, the system should be scalable to handle multiple ATM users simultaneously. Means if a user perform a operation certain a time, another user can also be perform operation at the same time. If the system crashes, it leads to damage. So the system should maintain large scalability to avoid uh, crashes. Okay, and our next slide is about transaction management. Okay, ATM operations are handled as database transactions. The ATM operations should ensure asset properties. We know asset properties means atomicity, consistency, isolation, and durability. Which means if atomicity means transactions are fully completed or rolled back, and consistency, data remains valid before and after transactions. We can also say integrity and isolation. Multiple transactions do not interface. For example, we are doing one transaction. In between, the another transaction should not interfere between the transaction, so that it should not lead to uh, inconsistency of data. Okay, and durability, which means data is permanently stored after completion, which means the transaction will be stored permanently in the storage. Okay, and workflow of ATM system means here we can see user inserts card and enters pin. System verifies user credentials from database, and user selects transaction type. Database process request, withdrawal or deposit. Account balance is updated. Transaction is recorded in database. Receipt is generated. Simple workflow for user, easy to understand. User inserts card and enters PIN. First thing. And system verifies user credentials from database. And user selects transaction type, which means withdraw or check balance or deposit balance, and database will process the request. If it is if it is withdraw, it will leads to withdraw process. If it is deposit, it will leads to deposit. Okay, and next thing is, and account balance is updated. If withdraw amount is decreased certain amount and according to the user design, and account balance will be updated if it will increased if deposited, and receipt is generated. The transaction will be generated in the form of receipt. Okay, and our next slide is advantages. Okay, it will provide secure and reliable banking transactions. It will ensure accurate data management using DBMS principles, reduces chances of fraud and unauthorized access, and it will support efficient handling large transaction volumes. And our next slide is limitations and challenges. It requires continuous network connectivity with bank servers. main limitation, it should connect every time 24/7. It should connect to the bank servers, and it should implementation of high level security can increase system complexity. As we know, for heavy security we need complexity of management will be there, okay, and hardware failures or system crashes may affect service availability and requires regular maintenance and updates. These are the limitations and challenges. And in conclusion, we can conclude the session now. Smart ATM Secure is a comprehensive database driven system designed to provide secure and efficient ATM operations by leveraging core DBMS concepts such as relational database design, normalization, and transaction management. The system ensures data consistency, reliability, and integrity. It effectively handles real time banking operations while maintaining high security standards through authentication and monitoring mechanism. Although the system involves challenges like implementation complexity and dependency on the network connectivity, it serves as a strong foundation for modern ATM systems with future enhancements such as biometric authentication and AI-based fraud detection. The system can be further improved to meet advanced banking requirements. And our next slide is thank you. I hope you understand the session. Thank you.